How long are you talking?
4 different sets of 8.
As long as it takes. So get focused. All right? All right, so that's me. Don't you know that? What is the measure of the other acute angle of the right triangle for number 1? 45, right? The two acute angles add up to what? 90, because one of them is
45.
no. One already is what? 90 degrees, right? That's the right triangle. All three of them add up to what? 180. So the other acute angle, just subtract what you're given from 90. So what's number 2?
30.
30. What's number 3? 66. What's number 4? 52. You guys are so smart. Don't even need that calculator, do you? All right? If you know, remember, when you have a right triangle, and again, this is something you should know. All right? One side's A, so that's angle A. One side's B, we call those the legs, that's angle B. And one side is C, we call that the hypotenuse. So the right angle is always at angle C. All right? So, what do you know about the two legs of a right triangle and the hypotenuse? Right, A squared plus B squared equals C squared. What do we call that? Pythagorean theorem. You guys remember that now that I reminded you, right?
Yeah.
Okay. So, to find the unknown, okay, for number 5, we go A squared plus 12 squared equals 13 squared. That's how we would set it up, okay? And 12 squared is 144, and 13 squared is 169. When you subtract them, what do you get? 25, so what's A? 5, right? Now the whole thing's all together. I can't move that down. So when I subtract 144 over, I get A squared is 25. So what do I got to do to both sides to get that 5? Square root. You guys know that, right? So for this one, A squared plus B squared equals C squared. So what's that equal? So your factor tree, what times what is 18? Let's try 9 and 2. 3 radical 2 is correct. 9 times 2. And what can you pull out front? The 3. Okay? So, that's just getting you warmed up for some right triangle trigonometry. Okay? All right, so we're going to understand and use trig relationships for acute angles. Again, when it's a right triangle, the other two angles are acute, meaning less than 90. And we're going to determine side lengths by using trig functions, okay? So, and we're going to learn about what a trig function is, and these are the 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Sine, they abbreviate as sin. Cosine is cos. Tangent as tan. Okay? Cosecant, which is the reciprocal of sine, they abbreviate as CSC. Secant is the reciprocal of cosine. These are all fractions, by the way. Those trig functions are fractions. Secant, again, is the reciprocal of cosine, which is SEC. And then cotangent is the reciprocal of tangent, which is COT. So those are the abbreviations you'll see for those 6 trig functions. Okay? And this should be a little bit of review for you. All right. So it's a function whose rule is given by a trigonometric ratio. A trigonometric ratio compares the lengths of 2 sides of a right triangle. Okay? So it's just a fraction that's comparing 2 sides of the right triangle. The Greek letter theta, it's that circle with the line there through it, that horizontal line, is traditionally used to represent the measure of an acute angle in a right triangle. The values of trigonometric ratios depend on theta. So it depends where it's at, where theta is. Okay? So that's going to be in your triangle, either here's our right angle. So theta is either going to be here, that acute angle, or up here. Okay? Okay, again, in the right triangle, these are called the legs. And then this is called the hypotenuse. Oops. T comes next. So the hypotenuse is always opposite the right angle. It's always the longest side. And then our 2 legs, okay? So it doesn't matter which one of these are, but those are A and B. This is always the C, all right? So like that, or A, B, C, but that's always C at the right angle, so that your Pythagorean theorem will work. Okay? That's our Pythagorean theorem. It works for right triangles. It has to be a right triangle, Trent, for that little formula there to work. Okay? Again, we're just getting an introduction to this stuff today. We're not having any homework, so just stay focused. Okay? So, there was this great mathematical Indian chief. His name was Soka This is how you remember the trig ratio. So S is for sine, so O is for the opposite side, and H is for the hypotenuse. And C is for cosine, and A is for the adjacent side, and again, H is for the hypotenuse. And then for tangent, O is for opposite side, and A is for adjacent side. Okay? So this is a little, whatever you call it, to help you remember what the fraction looks like. Trent, you're zoning out. Come on. You've only been here 5 minutes. All right? So again, sine is the opposite side over the hypotenuse. So for this picture, here's theta. So that's the point of reference. All right? So we're finding all the trig, or not all of them, but the first 3, the 3 main trig ratios for this right triangle. This is the most common right triangle there is, the 3, 4, 5. Okay, 3 squared is 9, 4 squared is 16. What's 9 plus 16? 25, and what's the square root of 25? 5. So you'll see 3, 4, 5 triangle a lot, or multiples of that. If I double each one, it'd be 6, 8, 10. You know, if I multiply it by 5, you'll see a 15, a 20, and a 25. Lots of times when you get problems, you'll see that triangle, that right triangle, okay? So, according to theta, the opposite side would be the red side because it's straight across from it, okay? The blue side is the hypotenuse because it's opposite the right triangle. It's the long right angle, not the right triangle, okay? It's the longest side, always, right? So, the side that's touching theta, you have two sides touching it to make angle theta, right? The side that's not the hypotenuse is the adjacent side. Okay? So for sine, SOH, S-O-H, opposite side is 4 over hypotenuse is 5. Okay? So that's 4/5, that fraction. Yes?
So anytime we go to do this, is the theta already gonna be up there? Or do we have
Yes. It will be there. Tell them.
So,
Yes.
Yes, there's a bunch of them. Yeah, that's in my first grade class that were there for a couple of weeks. Yeah. You're welcome.
Right, so for ka, cosine is adjacent side. So since theta is here, the adjacent side is the 3 over h, the hypotenuse, 5, adjacent over hypotenuse. Toa, tangent, O for opposite, A adjacent, so opposite 4, adjacent 3. So there's where those three fractions came from. Questions on that? Does that make sense to you? Okay. So again, it doesn't matter where theta is, but that's where you go by opposite, adjacent, and hypotenuse. Okay? If theta was up here, up top here, then sine is 3 over 4. I'm not 3 over 4, sorry. 3 over 5. They'll change. Those two will change. Because if I put theta up here, my opposite side's the 3 and my adjacent side's the 4. Okay? So theta's the spot you look from. It's your reference angle is what we call it, the point of reference for opposite, adjacent. And again, hypotenuse is always which side? Across from the right angle or the longest one, right? Because the 90-degree angle is the biggest angle. Okay? The smaller angle is going to be up here because the opposite side is the smallest side. So theta is going to be bigger. This angle here at the bottom is bigger than the one up top there. Okay, because of the sides longer. That makes sense, doesn't it? If my hands where I'm putting them together is the angle, and my fingers are close together, that angle's small, right? As my fingers get further apart, what happens to the angle where my hands are meeting? It gets bigger, right? That makes sense? So the longer the side is, the bigger the angle. The side opposite is. Okay? So if I label this, if theta was angle A, side A would have been the 4. Side B would have been the 3, and side C would have been the 5. Remember, side C is always our hypotenuse. Okay, is this making sense? Have you had this before?
Yeah.
I think you
Teachers, I
have.
apologize for the interruption. This message is for all students and teachers. The bells today are taking on a little bit different tone. No need to be worried. There is not an emergency. Nobody let the UPS man in. We're all good. So just continue on your day. We appreciate everybody's patience this morning. First day of testing. We got it done. Great job, everyone. Have a great day.
Okay. So, here's we got another triangle. Theta's in the same spot. So sine, again, is opposite 2 over hypotenuse, 2.5. Usually we don't like a decimal inside our fraction, so what they did is they doubled both of those. So 2 doubled is 4, and 2.5 doubled is 5. Okay? So it's similar to the one in the table we just did. Corresponding angles of similar triangles are congruent. No matter which triangle is used, the value of sine of theta is the same. Okay? The values of sine and the other trig functions depend only on angle theta and not on the size of the triangle. Okay? Just because the triangle is bigger doesn't mean that theta gets bigger. Angle will be the same. Okay, Scott? That making sense? That's all that example was. All right. So they already got the 3 sides done for you, right? So what's the sine, Trent? What?
I don't know.
You don't know? O stands for what?
Hello. I'm good, thanks. Yeah. No, I don't know when it started. I just, actually came out or went back in. I just talked to her for a minute before she went out back home.
It's so terrible.
When I walked
That's pretty self-explanatory. No, it's not.
Hey, are you focused now? Okay. Opposite hypotenuse. Okay? So, here's theta. Where's opposite? What's hypotenuse? There you go. Max, what's cosine?
The opposite and adjacent, or adjacent and hypotenuse.
Correct. Adjacent and hypotenuse.
So 24 divided by 25.
Correct. Wendy, tangent.
7 and 24.
Very good. Questions? Anybody? No questions? All right. You ready? Nicole? What sign, Nicole?
Yep.
Best thing clean for that.
30 over. Very good. Here's theta this time. Opposite's 30. Hypotenuse 34. Now, what should we do with 30 over 34? Reduce it. Always reduce, simplify your fractions. Okay. Kennedy? No, you just did the reciprocal of that. Okay?
Wait, what one am I doing?
We're doing, well, you don't know, do you? Let's do this. Sine would be next. Or we did get sine, right? Cosine. So there's sine, opposite over hypotenuse. Cosine is, so what's adjacent and what's hypotenuse? Is the long one, that's the hypotenuse, right? Now we use the 8/17. Okay. Andrew, tangent,
Opposite over adjacent.
yeah, so what's opposite? That is unacceptable. Here's the angle,
Okay, wait, okay.
opposite,
30, is it 30 over 16?
yeah.
Okay.
Oh my
God. Alright, then I'm good, I know it.
Then don't tell me you got no clue.
Well, I didn't for a second, and then I got it.
Is this that difficult? No, it's simple. Simple. Pay attention. I'm not asking that much out of you guys, I didn't think. All right, we'll stop there. Okay.
Wow, what a great class, guys.
My brain is not working. See, I just couldn't figure.
No one's really memorizing. You just gotta